So our main topic, the main thing for today's the thing that you're learning, it's can be summarized to slope of a point. Okay. Now, this is what I would consider a make or break moment for calculus, because this is the part where notation is very important. And if you don't understand why we have such notations, then we say, oh, if we don't have the notation understood correctly, then why are you doing all the work? Okay. So first, we're gonna attack this phrase right here, slope of a point. What the heck is slope of a point? Well, that's kind of strange, isn't it? Because when we were in Algebra 1, how do we calculate slope? Well, we say that if you have a line right here, you've got some x values, right? Some x value, then you got a dot right here, and let's just say the function is known as f of x, right? So the y value here, it's going to be f of x, okay? And then we've got another point right here. Now, in the past, we will simply use x1, x2, and y1, y2, but that's algebra 1. Right, and we're now in calculus, so we are a little bit more sophisticated nowadays. So instead of saying x2, we say, okay, now, instead of saying x2, we shall call this value by the x and the distance. And let's call this distance h. Well, that's why we call it that's why we call it x plus h. And what about the y value of this point right here? And we call it, well, the function is f of x, right? But since the x value is now x plus h, we call the y value f of x plus h. So before I move on, I would say, are there any questions with this notation? You good? Now, if you're good with the notations here, then I would say, let's go ahead and draw a line and do what we would do as in Algebra 1, which is to find the slope of these 2 points. We would say, oh, it's y2 minus y1 over x2 minus x1. And we simplify this to get a single h in the denominator. So you saw your notes, and I hope you found you now find this notation a little bit familiar. You know where this is coming from. Okay? Now, if everything is good at this point, then this is now the exciting part of the roller coaster ride. Now, as I said, back in Algebra 1, we only learned one thing, and that was slope between 2 points, right? How do we make sense out of this slope of a point, this thing right here? How can we make sense out of this? Okay. And we say, well, if you ask this to Algebra 1 students, they'll be like, what are you talking? We can only find slope of 2 points, right? There's no such thing as slope of a point. Slope of a point, it's a lie. Well, of course, it's not really a lie, but we need to find some compromise. Slope has to be between 2 points, right? So now we say, all right, now, let's not break what we learned back in Algebra 1. We are still going to say slope between 2 points. But what if we say these 2 points are really close to each other? They're so darn close that they are not overlapping, but they're just right next to each other. And if you use your naked eyes to see it, you can't really see it. So the analogy is like this. All right. The analogy is like, oh, there's a point right here. There's a point right here. And I'm going to move this point closer and closer and closer. And so close that you think it's a point, Nuh-uh, it's still 2 points. Okay, so that's the background argument right here. But how do we use notations to address such relationship that these 2 points are so close but not overlapping? And that's why we focus on this distance right here, the h. Well, what happens if those 2 points are very close to each other? Okay, what happens to the value of h? It shrinks, right? So if they are really, if these 2 points are really, really close, what would be the value of h? Really small number, close to 0, but not 0. And that's why we say the limit as h approaches to 0. Okay, that's the whole meaning of the presence of the limit. So if you look at this notation, if you don't understand every single component of this notation, then I would say you may want to spend time to understand this first before you move and proceed to anything afterwards. So this is why we say, oh, this is so-called the definition of the derivative, or the first derivative, f prime of x. Now, and I'm not going to stop right here because I want to make sure that you understand the meaning of this notation verbally. Because a lot of students, they don't understand this verbally. They just retain the formula, they retain this notation, but they don't know how to make sense out of it. What is this f prime of x thing? It is the slope of f of x at any x value. Now, just to give you some quick example. Just to give you some quick example. Now, if I say the function is x squared plus 5, for example, okay? Now, you will use the definition, and we will do the definition in a moment, but let me just go ahead, bypass the definition and say, all right, I got some magic power, and I know the derivative in my head. And that is 2x. Okay? Now, well, we'll take, like the spoiler alert, that's called power rule. Okay? But we'll get to the power rule later on. Okay? You still have to do the definition, but hey, let me go ahead and give you a rough sketch of this graph right here. This is a quadratic, right? All right, and shift it up 5 units. So what we're saying here is, oh, do you want to know the slope at some point? For example, at this point, let's call it x value of 2. This point is 2 comma 9, right? Because if you put the 2 back in this x right here, 2 squared is 4, 4 plus 5 is 9. That's the point. I want to know, what is the slope at this point? So what do? You say, oh, you know the x value, right? Just plug it in. And we say, oh, if you actually draw a tangent line, which we will explain a little bit more in a moment, the slope will be 4. Now, the whole thing about tangent line, if you remember from geometry, the idea of tangent line is that it is a line that touches a circle once and only once. Okay? And for us to apply this idea, this concept of tangent line, the concept of tangent line is that it would only touch the graph once and only once. So that's why we say here, and the significance of using the idea of tangent line is that the slope of tangent line is always equal to the slope of the point on the function. Okay? All right? So if you say, oh, I got f prime of x, great. That is a very versatile function. that you can use, and you can use it to find out the slope at any point on the graph. Are we good? That is the definition of the first derivative.